All right. Um, let's rock. Let's do this. So here's our select practice problem. So we're going to do number one. I believe there's three pairs of triangles on that one. This is the second row, or maybe four. I can't remember. I don't have. It's three. So yes, three sets. I think I'm looking at it. Actually, I don't know, but it's the second row anyway. And so we're gonna do the second row, both of them, and then I'm going to show you how to set up number three, and I'm gonna let you solve it, but I will set it up for you. So let's do these first. So I think it's best when you do these to basically figure out first of all which function you're gonna use. All right. So let's mark my angle. My angle is here, which means that this is my opposite side. The one across from the right angle is always the hypotenuse, and then the one alongside the angle that we're looking for is my adjacent, right? So I have my adjacent side listed and I have my hypotenuse listed. So adjacent and hypotenuse is cosine because that's ca, right? Adjacent and hypotenuse. So cosine of theta is equal to adjacent over hypotenuse. Let's plug in now our numbers. So theta, we're going to change that to x, so it matches the problem. Cosine of x equals 6 over 16. All right. So there we go. We're now going to flip that around because we want to solve for x. So to do that, we take the inverse function. So we go the cosine, inverse cosine of 6 over 16. So you switch these around when you do your inverse, is equal to x, right? Just this and this, basically pick them up and move them, right? So now it's just a matter of putting it in your calculator, right? And then you'll hit your second button, and you'll hit your cosine button, and then you will hit, your 6 divided by 16. You might have to close it off with parentheses. You probably don't necessarily have to. And then you'll hit either equal or enter, and then you should get your answer. All right, so that's exactly what I'm going to do. Second, cosine. I'm going to put in my number, 6 divided by 16. Close it off, hit enter. And I get 67.97. All right, now I'm going to write this down off to the side so we look at rounding, right? This tells me I got to round this up. So if I'm rounding this up, right, this goes to 0, which means that we got to round this guy up. So we get 68.0, put your unit on, and there's your answer, 68.0 degrees. All right, so next problem here, let's do a little thing there. Here's my angle. So that means that this is my opposite side, and then this one is my adjacent side. And the hypotenuse is right across from here, but I don't need the hypotenuse. So opposite and adjacent, TOA, that's your tangent, right? Tangent of theta is equal to your opposite over your adjacent. So let's plug in our numbers. So we have the tangent of, change that to x, is equal to, my opposite is 19 and my adjacent is 8. And so now we're going to use our inverse function to solve for x. So we're going to go with the tangent, the inverse tangent of, and then this is where you swap stuff around. So 19 over 8 is equal to x. Okay, so just throw it in the calculator. I'm not going to write it out this time. I'm just going to sort of talk you through it. So we are going to find our second button first, then we hit the tangent button, and then 19 divided by 8. Excuse me. Close it off with your right parentheses, and then hit enter, and then you get 67.16 with the 63 for a bunch of junk after it. So we are going to round that to 67.2. So it's going to be 67.2 degrees. Okay, I always round to tenths on these unless otherwise stated. Okay, so 67.2 degrees. All right, let's do our last problem. So number 3, and I'm not going to do the whole thing. I'm just going to set this up for you. So let's find it, right? It says the airplane's flying at an altitude of 3,100 feet, right? So when it begins its descent. So descent means it starts going down, right? So if we're starting here, right, and we know it's at 3,100 feet, right? Okay, and I have a feeling they're telling me this for a reason, so we're gonna just draw a thing here, and we're gonna say this is the ground, right? And it says if the runway is 104 miles away, right, at what angle does the airplane descend, right? So the thing is, this is 31,000 feet, okay? And then it says the runway, so let's say this is the airport, right, where the runway is. So we want to know this, right? Or actually, we do know this. We know that it's 104 miles. So it's 104 miles. Great. And so they want to know at what angle does the airplane descend. So this is going to be the path it's going to take. It's going to be this straight line down here. Apologize for that not being perfectly straight, but you get the idea. All right. And so now we've made a right triangle. Okay. I don't know this, right? And I don't need to know that. I know this and I know this. And they are asking me for at what angle. All right. At what angle does the airplane descend? So in other words, if this is your horizontal, right, they want to know what angle is it descending from here, right? So they, you can think about that. So there's two angles you're going to have, right? Because it's going to be 90 degrees, all right? And so what we'll do is we'll find this angle first, okay? So let's find this. This is going to be our theta, and then we'll be able to find this one by subtracting it from 90, okay? So because this also makes a right angle, right? So let's do that. The other way you could do it technically is remember that you have alternate interior angles, and this is going to be equal to this one. But we won't confuse anybody with that right now, and we'll just go ahead and we'll do this. So if this is my angle, I don't have the hypotenuse, we're going to use tangent. So we're going to go the tangent of theta, and that's going to tell me this angle right here, right? I don't want that. I don't need that one. I need this one, right? Because if you're descending, your angle of descent has to be related to where you are at that time. So if you're going straight, your angle of descent has to be like degrees away from where you were going, right? And so hopefully that makes sense. Your tangent is going to be your opposite. My opposite is 104, right? Over, and it's 104 miles over, and I'm writing the units in for a reason, over my adjacent, which is 31,000 feet. Now what we have to do is we have to have the same units. I can't just put this in like this. It's not going to work. So we're going to go the tangent of theta is equal to, we're going to convert the miles to feet. So let's do that off to the side. So we have 104 miles, and the way to convert that to feet is to remember that there's 5,280 feet. Oops. That got really weird, right? So we have 5,280 feet in 1 mile, right? So that's my conversion, right? And you always set it up so that this cancels with that, right? And so basically just multiply 104 times 5280, right? So 104 times 5,280 is equal to 549, 120, right? So we're going to rewrite this as 549, 120 over 3,100. Now we can solve for theta by doing our inverse function. So we go the inverse of tangent is equal to this very large number over this large but not as large number, and that is going to give me my theta. So I would suggest you should just be able to put it in a calculator exactly like this. So 549, 120 divided by 31,000, close it off, it equals, and then what I get for that is I get theta is equal to 86.8 degrees. Okay? And I know I said I wasn't going to solve this whole problem, and you guys are lucky because I actually am solving the whole problem. And then to figure out what the angle of descent is, So this is what I want. This is what we're after. We want to know that angle right there, right? So to figure out what that angle of descent is, then all you have to do is recognize that, hey, this angle and this angle here make a right angle. So to figure that out, you just go 90 minus 86.8 degrees. Okay, it's going to give you your angle of descent. All right, and that is going to be 3.2 degrees. All right, so you're going at a 3.2 degree angle, so it's very slow angle, right? You're about 6 miles up here. You got to go 104 miles. If you think about that, you just kind of take it easy. And you don't want to go down too crazy either when you're in an airplane, or you're going to freak everybody out, right? So that's why they go low and slow and nice and safe. All right, so hope this is helpful to you guys, and enjoy.